Which one? This one. So, okay. So this is your case files. This one overset 3 or overset 2 dada? Hello?
Yeah, overset 3, overset 3.
Overset 3, I should check overset 3. And here you have 3 meshes and 1 case file. Let me try to open this. So is that okay Dada if I delete this one and use the separate thing? Hello?
Yeah, no problem. You just continue with this overset 3, no problem with this.
Yes, Dada, I'm going to delete this D and E and I will create the case file next.
Okay,
Can you
sure.
delete it?
Yeah,
Okay.
yeah, sure, go on.
Thank you. Yeah, it is busy actually. I should close few things. I'm closing overset 2 then.
Everything's.
Yeah, overset 2 I'm just closing for time's sake. Because multiple files are opened at the time.
That's why system is slow.
Yeah, and the system is also.
You have been using Paramsat, no?
Yes, Dada.
What is the process? Gradient part.
Your voice is actually breaking, Dada. I'm trying to.
Just a second. Let me connect my headphone properly. Yeah, it's fine. Internet is.
Yeah, it is now okay, Dada. So I just deleted the old one.
Okay.
And here we are now at. Maybe there is a. This one also I would like to delete. And I will take a new one. So you are just connecting everything, right?
Yeah.
This may take time for updating.
It takes time.
Okay, I should update everything. Because after connecting to that, these things are still pending of rebuilding. So we should update those things and then open the Fluent setup.
That's why the June 13, 10 and what was.
Maybe there's an issue. So how many parallel licenses? Serial, double precision, 4 license, 4 parallel process there?
5, you can also go for 5 also.
I think we cannot go 5. Are you sure that we can go for 5?
It's a 5.
This is logical 6 cores, maximum of 6. 6 core 6 process, so we can use a maximum of 6. So I will use 6 for sure. Double precision parallel 6 and okay, that's fine. So everything is now ready here.
Okay.
We have interior overset A and a zones called surface body 1, surface body 1.1. These are the zones.
These are coming solid.
We can change it, that's not an issue. Just clicking on it and where.
Right click on the type and then it will be fluid.
Okay, okay, here it is. Yeah, I understand. So these are all fluids now. Let's look at our mesh ones. So you're using water, right, Dada?
Yeah, yeah, yeah.
So this is the mesh you have developed with the 10C radius.
Yeah, yeah, 10C.
10C radius and two tandem wings flapping, and number of cells are
Around 2 lakhs is there something.
2,74,000. 2,74,000, and the quality of the cells are like minimum orthogonality 0.04. Right now it may not cause any issue, but if divergence is detected, we should check these things later. And now I will come from the general tab. After we just imported our three meshes here from the general, we are using transient simulations and
Yeah, yeah.
plan. So nothing to change here, only the transient pressure based, everything is okay. And your model is
K omega.
K omega.
Yeah, yeah.
Any other things, your SST or low K omega standard?
Standard only. That
Okay,
curvature corrections you can consider or
curvature correction. Anything else?
no, no.
Okay, then. So models we selected and
We need
fluid.
to, yeah, yeah. Fluid air
Okay.
we need
We
to
are
add
going to add
water.
water,
At the end, it will be water liquid will be there.
water liquid, and copy, close. After copying, we now have the water as the liquid and fluid constant
It's fine.
value. Okay, everything is okay. And this fluid one, it is not necessary now, so I am deleting it, the fluid one. We have water liquid, and we should change the cell zone conditions to fluid, from
Fluid.
fluid to water liquid. Okay, and now I am changing everything from water to, I mean, air to water liquid. Are you able to hear me, Dada, or my voice is very low?
No, no, no. It's fine, fine, fine.
Okay, I'm changing it to water liquid. So now I can delete the air just for safety. I'm deleting it
Okay.
because we have now only water liquid. So if we miss something else, then we cannot delete the air. So all the three bodies is now with the fluid
Fluid
zone of
surface
water.
body one.
Yes, and next, boundary conditions. Airfoil wall. Airfoil A is the wall. Let me display the airfoil A. So airfoil A is a wall and airfoil B is also a wall. It's okay, Dada. And velocity inlet.
Yeah, three boundary inlet. Velocity normal to the boundary. No, it will be velocity with direction. Velocity inlet conditions.
So this is okay. Three directions. You are saying it as inlet.
Yeah, velocity with x direction, and that is normal to the boundary was the select. Okay.
Magnitude and direction.
In direction x velocity 0.125. 0.125.
5. Okay, Dada. X component 1 and Y component 0. No
Zero. Yeah.
suppression.
Okay.
And anything here we're changing?
Yeah,
Intensity.
with hydraulic diameter.
Okay, and intensity of
Intensity 5, or we can say for the, if we take overset A and B, then we increase the hydraulic intensity to 10.
hydraulic diameter to
0.04.
0.04 and the intensity is 5% is fine.
Yeah, yeah, 5 is fine.
Okay, and I said this okay. And these three things are interior. We nothing to change here. And the pressure outlet.
No.
Outlet you can set it as a normal to boundary, or you can use okay. For the time sake, I set it as a normal to boundary. And intensity and hydraulic diameter 5% and 0 point. You said something
0.04.
0.04. So nothing else to change here. And I will close it. Okay. Let me check the overset boundary conditions also. The overset A, overset B. So these are
It
also
is.
fine. You give these conditions are also correct. And overset A, these are automatically set to the type overset. So
Yeah,
nothing
it
to
is.
here.
Nothing to change there.
And now what we are going to do is we are creating the overset connections. Here it is the overset connections and this body.
Surface 1.1.
Now, what is the name you are giving the
Overset 03, I wrote there.
VS03? Just for a shortcut, can I name it as OVS03?
Yeah, 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 yeah. Fine, fine. Just for the
OVS0.
understanding part.
Okay. And I'm creating this overset connection. After creating, I will click the close button. And here are my interference
Yeah,
overset
yeah.
03.
We got overset 03. Yeah, right.
Okay. And nothing to change here. Everything is fine. And let's go for the dynamic mesh. Before I will check the dynamic mesh here and smoothing. Let us load the UDF file. You have the UDF file loaded in
Yeah, in
this
that folder only. In that folder
that
only.
folder only. Huh?
Yeah, yeah.
Okay, let me check because it is uh, overset 03. We are here and
Tandem flapping is one folder will be there.
properties. And it is FLU minus 1. We have to go to the folder FLU minus 1.
Or we can also build for the plus.
Code files are should be located in the same folder. That why better it is to use the old libudf folder.
Yeah, yeah, yeah. The same C file is there in that folder. Here,
Overset
overset
0,
same.
this one,
Yeah,
okay,
this
and
one,
overset
tandem
0.
flapping.
Tandem flapping is the code file, but libudf file is
In the, yeah, yeah, that is in the DP0 flu
fluent.
fluent.
No libudf file there.
We need to just load that file.
Okay, then I will uh, compile it again.
Yeah, yeah,
So
we need
is
to
it
compile it.
compiling directly without
Yeah,
this?
we can compile from this here only. Just open that fluent part.
Okay, Dada.
Compile from there. Yeah, go to this function,
Okay,
compile,
compile.
this
Can
add.
I? Okay.
You select this file. Okay, okay. Then build,
Yes.
and you can
So it
load
is
from.
directly checking your Visual Studio environment. No need to
Okay.
go for extra, I mean, additional
No, no,
direct.
no. It's directly loading. No
It
problem.
is direct.
Earlier it was problem with this my system. My laptop was in this system. It is okay.
Okay.
Load,
Now it is okay, and then I can no
load
errors. I
this.
hope
Yeah, yeah. It's done. No. Oh,
it's
yeah, yeah.
done. So we just loaded the libudf files. Mm.
Then you can go for settings. This one, settings, cell volume or that cell distance method.
Okay. After dynamic mesh, I am going to the settings, and it is smoothing.
Diffusion.
The setting is diffusion, boundary distance method, or
Boundary distance method.
this is cell volume method. I mean, nothing to deal here with dynamic measure. Only overset is different thing.
Yeah, yeah.
There, diffusion is not a. So far, with my knowledge, diffusion is not a key parameter. So I'm just considering it like that. all the
Yeah,
defaults.
okay.
I'm not changing anything. All the defaults I'm using, and then I will create and edit. In this create and edit, I will go to
Surface body 1.1.
surface body 1, and this is
The
some
same UDF.
yeah,
That X will be 0 - 0.03
03
and Y will be 0.04.
4. Anything else, Dada?
Nothing to change.
So I'm creating it, and the second one is
Surface body 1.1.
1. And that's rigid body, and this value is 0.03, right?
0.03. Yeah, yeah, right.
Remaining is same.
Everything is same, right?
Okay, we created these two, and nothing else. Shall we check the mesh motion, or shall we proceed directly to the run calculations, and there we can check?
There we can check only.
There we can check. Okay. And the reference value, let us compute
Reference
the
value
inlet, and area is
0.04. That is
okay.
the length only, chord length only.
This is the
Depth is 0.04.
depth is 1, length is 0.04. Okay, and pressure, everything is
Same and
same.
same. Same and same. Now initialize with hybrid
And
initialization.
now we can initialize that. Then before that, coupled scheme is okay. Second order point.
First order implicit is okay, fine. That is
Okay,
transient
so
coordination.
I'm not changing anything here.
Yeah,
If
yeah.
you want accuracy, you can change those things. And current number, I want to set is the 1. For incompressible flow, we can use the high current number also. That is not a big thing. And additional things, what I want to create is lift, drag, and moment. Report plots new. I'm creating these force components.
Force component drag,
Lift,
drag coefficient is there around aerofoil B.
only airfoil B,
Yeah, yeah.
not airfoil A.
No, no. Only we are checking for the second one. Just
Okay, so airfoil B and the drag coefficient, report file, report plot, and print to console. These 3 points I'm checking them.
name. I just check that
Drag.
name. That is
And you want to check this the drag. Can I say drag coefficient or drag?
drag coefficient. Write it. That will be better.
Um, then I will use the shortcut
CD.
drag
CD.
COF.
Okay, fine.
Is it fine, Dada?
Yeah, yeah, fine.
Okay, drag coefficient. And then another one, force report lift.
Lift is there.
B
Airfoil P. Lift.
and okay.
That frequency we can also check, no? We can write this every time step. We need to write this lift and drag order after some
It will
interval.
do automatically for every time step, Dada.
Okay. For transient,
Because
it will be required
yeah,
for everyone. No.
it automatically write it. The default thing is it writes for every time step.
Okay, fine.
And we can also write the moment coefficient. Any changes you want to do in the moment, I mean, moment location where you want to, the center of the airfoil B,
That is
0.00.
0.03 and 0.04
And the
moment.
axis 001, that is fine. Frequency 1. Okay, Dada. And it is moment
Name.
coefficient. Okay. So we just added all the 3 report to plots. These things will be here. And
One
report.
more contours and animations we need also same.
Yes, Dada, I will change those things.
0.05. Yeah, it's fine. 10.
I am using my defaults. Actually, -5, 10 to the power -5 is sufficient for everything. And for
Yeah, yeah.
continuity, you won't get converge very easily. So -4 is sufficient for 10 to the power for continuity.
Okay.
So those are depends upon the user. And
Initialization.
um, I will go to the initialization data, but
Autosave.
before that, I would like to change save data file for every 10 time steps. Can I do that? 10 time steps or 20 time steps?
10 or 20. 20 is fine.
20, okay. So only modified retain the most
It's in data.
and file name with time step. Okay.
Fine.
So nothing to change here. After every 20 time steps, it will change automatically. And then what I have to do is, what the point we are missing is, uh, I told you that the overset has some commands that can't be defined with the user interface. We have to type the names itself. That is, first one is define, should start with the define. And then if you press enter, you can see here, after typing define, you can see there is a overset interference. Dada, can you see this?
Yeah.
So after that, you can use that overset interference, or just type overset and then press enter. It will automatically give you the select the overset interference. And if you want to look at what are inside this overset interference, inside it we have many things, right? Create, delete. What the things we need is, we need only uh, options. Yeah, here is the options. We need to enter into the options next. So in that options, we should select the donor priority method. In that donor priority method, you can see there is a donor priority method in the first column, and then you can just type the donor and select enter. It will ask you few questions. Enter the donor priority method, 0 for cell volume based and 1 for boundary distance based. So because your boundaries, I mean wall boundaries in this tandem flapping are very close, boundary distance method is necessary. So that's why that's what I'm mentioning as boundary distance method. So after this, you press 1 and enter. So now it will create the mesh or overset settings according to
Boundary distance method.
boundary distance and based upon the boundary walls. And another thing you can also check is, I will quit in the sense it will come out with one, I mean, we come out to one option back. So now you can see mark cells, list, grid properties. What you can do is, you can use the grid properties. So I will type grid and press enter. So it will show me grid properties regarding the OVS03. OVS03 is nothing but the overset interference we have given at the starting
That we
of
have
the.
created, no? Yeah,
Yes,
yeah.
sir. And you can
See.
press enter. And background zone, we are not preferring any importance to the background zone, so it is 0. And we are giving the preference to remaining
Component.
component mesh 1. So give it as 1. Whatever the components you are giving preferences, that means the system can understand this is the key component that I should give priority, and a good mesh like that, if I say. So component surface body 1 I should give as 1, and another one is the component zone, that is surface body 1, that I should give as 1. So now this system is ready to understand, I mean already is understand how, what meshes or what zones I should give priority, that those things we said just said now.
Okay, fine.
So these things comments you should remember that, otherwise you can copy it and paste after this. If you can directly check it that, or you can, if you want this, you can copy these things.
I will do it in the command prompt. I got what to do. Boundary distance method, I need to check it, and grid priorities, two things.
Okay, Dada. So these are the things important, and next things the graphics, because before initializing, I mean without initializing the system, we cannot load
Make
any graphics. So what I do is, I first initialize with hybrid initialization, and then click initialize button. So and hybrid initialization may take a few minutes,
yes.
depends as well. So it's faster, so it's already ready. Then we can now check our mesh, the overset mesh. The setting up domain, we can click the display and we can select everything and select the overset also. Now we display, now you can see that we are at coming to the portion of the these two walls, it is like a created uh,
Boundary
yes sir,
wall, that overset has been done.
overset has been done. And keeping in mind, I mean it is keeping in mind its own mind, I don't know what mind it is using. The airfoils, here is the airfoil wall distance, so the connection should be minimum here.
Okay.
And remaining things you can see, this is overlapping a large.
Yeah.
I feel if you can generate a smaller size of mesh here, it will be good for the overset interference. I mean, cells are looking large here, whether
Yeah,
it
yeah.
is fine. here to surface, but here it is looking large.
Okay, I will change. It's I think his face sizing was 0.005. I need to check it with less 0.001. That will
Yes,
be
brother, you can do it wherever you want a less number of size. You can modify there. That's important. So our meshing is also fine now. So we can close it. Now we can generate the graphics here. So what I will do is I will create vectors for verticity instead of okay, velocity is maybe better now for few case files. I will right click and click on the new, and instead of pressure, I will use the velocity magnitude. I don't select anything here, and I will deselect the global range. I will select the field.
filled. Okay,
To see the field, I mean entire thing field, we should not select anything here. That is what the problem with the 2D mesh. In 3D, if you want to see field component, we should select the respective component. But in 2D, we should not
it's not
select
required.
anything here.
Okay. It's
We should not select anything here and then click save and display. Now it will display with the full contours. Otherwise, if I select all the things and display, this will give the mesh also without any filling.
okay.
That is
Fine.
the problem. So we should not select anything here and click on display. Now it will give a clear display.
Yeah. It's fine. Uh, Name velocity contour.
Yes, Dada. So to remove these two circles, what I do is I will deselect everything and display and close, and I will edit this again. Why these two are still displaying? Okay, let it be, Dada. I don't know why these two are still displaying, but we can manage these two also. For the time's sake, I'm not focusing on these two.
I think something is selected in this part. Nothing
Where
is in that bound contours only. No, nothing is selected.
surface it is. No, Dada, nothing selected. Okay, that's not an issue, Dada. Let's keep those things as this.
Okay, fine.
Maybe. And after creating this contour one, we can rename it as velocity. I will raise the velocity. So, okay. Now I will save the animations in the solution animations in the right click and click new. And after every time step, instead of iteration, I will select it as every time step and save storage format as HSF. And I will use um, this velocity contour. Rename this just as velocity, and I will select this animation 1 or velocity 1. We'll rename it as a velocity 1. Looking for the pressure contour, Dada. If you face any issues later, please kindly let me know. I mean, whatever the verticity that is generating, and then I will click save.
That storage type
Okay.
SSF file will be already there. Or
HSF is important that it will store automatically as HSF in your this folder, the same FLU1 folder.
yeah.
It,
Again,
why this HFS is important is next time if you want to see the results, uh,
okay,
just a minute, Dada, a call.
just okay, fine.
So now, if you want to next time see the animations,
Okay,
hello, without
yeah.
loading case and data files, you can directly use this HSF files. That is what the uh, best thing with this HSF files.
Okay. No,
So
no.
I'm
I tried to load with that Windows Media Player. That was not. That format was not compatible.
that
Tried.
I think a small trick is there. If later after your simulation is done, if you want, I will show you that.
Okay, sure.
It won't happen directly, but a small trick is there how to load those things.
Okay.
Okay, now I will say it as velocity 1 and I will click on save and I will close it. So here it is saved, and now we can run our simulations.
Can we check that that solution, this HS, okay, that every time step you have studied, no? That
At
we can
every
animation
iteration, after every
every
iteration, animation will start after every time step, one time step.
every time step. Okay.
So now I'm giving the time step size is 0.01. Just for your sake, you can, okay, 0.001.
Fine.
Or shall we reduce the time step to see the motion of the airfoil?
Okay. Reduce it to 0.01.
Because this is not a final mesh, right, Dada? So you just want to
Yeah.
see the whether it is any problems or the. So I will reduce it to 0.01, and I will say to number of time step as 100. You can increase it later, Dada, and I will leave these things as 20 and 1 and 1 just to see the mesh motion and velocity whether they are going under control or any vorticity that is forming that what we seen in previous simulations. After you finalize your mesh, you can use the same settings and you ensure good time step and good number of its sufficient iterations, sub iterations.
That
So can you use
reporting
it?
interval should be one, no? For transient.
Reporting interval and update interval. These are not a big matter that you can use it 20 or whatever.
Okay. Okay. Fine.
These things can be left it as default, and we can click on. Can I click on calculate?
Yeah. Yeah. Sure. Case file.
So this is the case file that is necessary for to load in PermSheet or anywhere or any separate fluent file. So you need those things. So that's what I asked previously. Now it is still running in the workbench itself.
Yeah.
Later on, if you want, you can separate those case and data files, and you can use it those things separately.
Okay. I store the same UDF file and that
Yes,
leave
sir.
UDF and case file.
Case file is sufficient. The UDF and case file, everything will comes and you can start running there.
Okay. Yeah. At
It
this
is
point.
looking like it. Let it run for few time steps further whether it is working or not. Residuals are not okay to look. Okay, it may get divergence further.
Yeah. I think so. Continuity part.
We can reduce the time step also, but the thing is, it is
You can see at the bottom part. I think
bottom
that
part
vortex.
something
Yeah. Vortex is getting is there.
is happening wrong. It's not vertex further. Something is wrong where what I can say may because of the solution or
Yeah. See at the bottom and at the interface.
shall we try for the low time step data
Yeah.
0.0
Yeah. 0.02. Try that.
at 0.1?
Yeah. Yeah. Okay. Fine.
I will initialize it again. So 2 lakh cells, it is actually 6 cores. 6 core, 2 lakh cells. It is actually still running faster than what I can say is.
6 core is there, no?
6
Okay.
cores is this, and it is actually, I can say it is running still faster.
Let's check for 1 or 2 time steps net after the convergence. Yeah, I think it is going. It looks good right now, but after,
Convergence is the issue that if no convergence is there, something will happen at some point. And our orthogonality. If you see the orthogonality is the 0.04, it is not okay that if I say at those locations, solution there is for choice of getting divergence or large values in numericals. You
then
you better always try to, I mean, while doing your mesh, you better always try to reduce your orthogonality as I mean, increase your orthogonality as good as 0.3, 0.4. For structured mesh, it always you can get a maximum of 0.8 also sometimes. Structured mesh is always good for if we want to get orthogonality,
yeah,
but unstructured we cannot comment anything there.
some of the cells are bigger. I think I should refine this circular region with that uniform mesh. We can,
And you can reduce the size of cell size also.
yeah, one thing, one thing we can. I changed the behavior to the hard settings was too hard, but after that it was also some of the cells were triangular and some of them were quadrilateral type.
Maybe if you any tutorials will help you that for to. Now I think it is going okay compared to the previous because your residuals are good.
Yeah.
Compared to there is nothing like previous. What we have seen is some unnecessary
Vortices were there at the boundary
large
of the
areas
overs.
of now I think it is resolved. Continuity is also reaching -4.
Yeah, yeah,
You should monitor your lift coefficient and drag coefficient plots also. I mean, these things should be periodic with time and not such a high values like this is like 16 and 19. I have a little doubt why it is getting 16 and 19, but you can monitor it later. This much of high is not an okay thing to see.
that lift coefficient should be less. Is
Actually,
around,
this is around 1 or 2, maximum 2. I don't think because maximum 2.
is higher. It is
It's
around.
very there to 614 to 18 is really high. The drag coefficient is getting reduced. Drag will help you. Now you are getting convergence also. Okay, I hope this will help you, Radha. If
Yeah, yeah,
still it's problematic, let's start from meshing then next time. I will
yeah,
check you. So far, I haven't focused on your mesh, but problems with mesh also will be there.
yeah, yeah. I think it is there. Some of the cells are not uniform. Some of the cells.
If it is not working, then I will focus on. Better you generate the structured mesh with these uh, ellipse airfoil, ellipse kind of airfoil. We can generate the structured mesh. That will be very good.
I need to go for this circular overset or that elliptical one. This
You can
overset region.
overset region can be I'm not getting the other.
This overset region is circular one. No? This
Okay.
radius.
Yeah,
I
circular
should
one.
change is to elliptical or something. It is okay. Or
Uh,
I should make a single line partition and just divide those segments in some particular number of divisions. Then we can get this regular size meshes.
it is not mandatory to use a circular. That's your wish that I think even ellipse is also okay. But we can have you try it the other with ellipse. If ellipse is giving a good orthogonality mesh compared to the circular, then we can work with ellipse only. Unless we try that, we cannot comment it. I mean, I don't
Otherwise,
have.
okay, I need to check for the orthogonality, that will be around
Generally,
0.5.
structured mesh that will give you, I mean, structured mesh that will automatically give you a good orthogonality. If still it is problematic, then we have many things to deal with that. And if you see here that there is something like a gap between these two.
Mm-hmm.
This area, this is the problems with the overset mesh. If we refine the cells here, then these kind of gaps will be eliminated. I to face these kind of issues where there are the large cells or some interference of two overset meshings. It will create a gaps. Um, we can check it what these kind of cells are, or is it problematic, or but it won't influence the solution much. What I see is,
Right now, it's going good.
if it is problematic, you can let me know that I'm. Uh, this this one. Okay, I hope it will go good and
Okay, I will check that and I will tell you if anything goes wrong. Okay.
okay.